All right, let's see. I'm going to pull up the Etherpad and we can get moving. I figured people might slowly trickle in, but it looks like we do have core people now. So, okay, let's see. I have got two new PRs this week that I saw. One is from me that is looking at doing trying to make a really quick and dirty OMAP benchmarking implementation in our uh, object store test suite. So this is really just taking the like simple OMAP test that we already have and more or less souping it up a little bit with the ability to write to multiple objects, do lots of keys, and then more or less do the same test that it's already doing and timing them. Uh, I imagine that there's going to be room for improvement here for sure, but this is just kind of a first pass attempt at it. Um, I'll talk about this a little more later, but it's definitely showcasing some interesting things. Um, the next new PR is from Gabby, and this is his PR to remove allocations from RocksDB. And Josh and Igor both have reviewed it. It looks like there's maybe a couple little things that could maybe be worked on or improved, but they're both on top of it and working to help make it good, or at least ready. Not that it wasn't already good, but ready for being merged. Um, okay. I did not see any closed PRs this week, but I just realized I don't think I looked through the list of PRs that were submitted this week and closed. So it's possible I missed something. Please feel free to speak up if there's something that you know that closed that I missed here. Updated this week, we have a PR from, I hope I say it right, Shuhan. That is kind of like two separate PRs in one. Scattering alien store threads across separate CPU cores, but then also has a separate thing kind of bolted on as well. So Kifu and I talked about that this morning. I think we just need to separate that into two separate PRs. The first is pretty straightforward for actually distributing threads across cores. That looks great. I think that's just fine. We should merge that. The other piece is more complicated and maybe isn't quite what we want. So more discussion needs to happen on that part. Let's see, there's another PR from Shuhan, optimize Crimson OSD's client request process parallelism. I think that was reviewed and it's in testing now. Let's see what else. Actually, I am wrong. I had this in the wrong spot. Adam's PR to distinguish between buffered and direct I/O in BlueFS. That was a bug fix, actually, more than anything. We weren't reporting the correct state to RocksDB. That's been fixed and was merged by Kifu. And then there's the Ceph volume retrieve device data concurrently. David Galloway just commented on that. I don't know what exactly is the holdup still on this one, but in any event, that is still being discussed and worked on. Let's see. So no movement for this BlueFS buffered I/O, but just before the meeting last week, or kind of, yeah, it was really just before it. Adam and I had done a bunch of work going through the RocksDB code for about 3 hours to understand the route that we take when doing iteration all the way back to BlueFS and reading data for RocksDB. So I can go over that a little bit today. Adam's not here, I guess, so we can discuss it at least a little bit. Otherwise, I don't think there was a whole lot of other things going on that I saw. Sam has a whole bunch of stuff happening with C-Store, but I don't know if it's really exactly performance related yet, so I didn't include it in this list, but definitely there's a ton of work going on there right now. Anything I missed, guys? All right. Well then, for OMAP performance, this PR that I've got for doing object store or test OMAP bench, I'll post or I'll paste it in the chat window. Here we are. So I don't totally trust this yet, to be honest. The file store results look really, really good, and I don't totally know why. It's possible that file store just uses so much less memory that RocksDB can utilize the page cache given a small container memory limit effectively, and it's still just doing really, really well. But even in other tests, it's doing surprisingly well, so I need to understand this. But the gist of it is that in BlueStore, we're seeing really, really slow iteration over OMAP, and seemingly maybe slow OMAP put and get performance as well. It's really nuanced and hard to figure out. The RocksDB code that is involved in all of this has changed dramatically over the last couple of years. So there are multiple code paths involved, depending if you're doing direct or buffered I/O. There's a lot of different things that could impact what's going on. Given what I'm seeing in my test that I don't totally trust, I think we're seeing a really, really obvious performance hit when the block cache in RocksDB is being heavily contended. When other things like onodes or maybe allocation data or other stuff is cycling through the block cache, my guess as to what's going on is that that's basically forcing the SST files that were being read for iteration out of the cache. We're going back, doing prefetch. It's all very slow, reading from disk, and the iteration step is we might even be iterating over like a long time period where in between other stuff is forcing those SST files out of the cache, and we're actually reloading them. I don't know yet, but it sure seems like that's what's going on. It'd be really nasty if that's the case. In that PR though, if you look at the last set of tests from like an hour ago, you can see there's this huge disparity in BlueStore direct I/O iteration performance when we have a smaller OSD memory target, so a smaller RocksDB block cache, and a bigger memory target, and thus a bigger block cache. It's like a 10x difference. So that is kind of what I'm going to try to focus on, is understanding exactly what it is. Doesn't look to me right now like this is a bug exactly in RocksDB. It's not like when we're doing prefetching or reads for iteration that we're not putting stuff into the block cache. I've seen some evidence with wall clock tracing that we are in fact loading data into the block cache. So I don't think that's what's going on. It's that we're just thrashing it really badly. This may just be an indication that BlueStore is trying to use RocksDB for too much. We already kind of suspected that anyway. So that's kind of what we've been working on. If people are interested, we can go through like a walkthrough of the RocksDB code, but it's pretty esoteric. I don't know if folks want that or not. that's kind of high level. Comments, questions, thoughts?
It's really interesting, Mark, what you brought up about the difference between file store and boot store. I wouldn't have expected that.
I don't totally trust it yet, but yeah, it's a little disconcerting.
Yeah, yeah. And maybe you're right. Maybe it's an artifact of the memory situation. But
It might be. If you could imagine, right, that if with file store we just have enough memory in the page cache to be able to keep those SST files in cache for iteration, you could see a dramatic difference, right?
yeah, that's true. Yeah, because as soon as you're going out of cache, it's a tremendous hit.
Yep. I think I'm going to try even limiting the C group limit even more and see if I can make file store look bad, just to see if I can prove it.
Yeah, yeah. I could very well be part of it. I mean, since file store is able to take advantage of the page cache a lot more, it's kind of implicitly getting a lot more memory from the system than Booster is.
With C group limits, I think, but I'm not sure that also limits your amount of page cache you get, right?
I'm not sure about that. I don't think it's necessarily accounted for on a per process basis, since the page cache is kind of shared system wide.
Well, I keep going back and forth on this because that's kind of what I'd originally thought, and then I saw some very ad hoc knowledge of various forums claiming it did, and I am seeing with Blue Store a change in the performance of iteration with buffered I/O when the C group limit is increased, even if the OSD memory target is left the same.
Interesting.
Exactly. That
That's
makes
definitely
me
something
think
we don't understand about the model then.
yeah, exactly, right? There's something going on here, and I don't understand what.
Exactly. Yep.
But
Yep.
yeah. So yeah, anyone that's interested in this stuff, please look at the benchmark code. I don't really trust it. It's very poor. It's basically just taking the existing test and throwing counters around it. I haven't played a whole lot with collections or any of this other stuff yet, so I'm guessing that I could probably improve this dramatically. But yeah, that's I guess it is what it is. Sam, I don't mean to pick on you, but do you remember with FileStore, since you worked on it so much for so long, would you expect really fast OMAP performance with it? Does it make sense to you, given the
memory theory seems good. You should look at that.
Sorry, what was that, Sam?
The memory theory seems good. You should look into that.
Yeah, okay. So yeah, that's kind of where we're at with this. I think I include a couple of wall clock profiles of an early version of the benchmark in the PR. There's definitely some crazy stuff going on in here. I forgot. I still need to run these tests with telling TC-Malloc that it can have more thread cache because we don't. Is not kind of implicit when running Ceph test object store individually. That'll probably help with TC-Malloc a little bit since we saw that show up in the profiles. Yeah, otherwise just lots more investigation that needs to be done. Hopefully we'll get to the point here though where Blue Store is as fast as FileStore seems to be.
I also thought it was interesting that the hashing was showing up pretty high in your profiles for Blue Store. Just recalculating the hash for which cache shard to access, it looked like.
Yeah,
It was like 10%.
I do kind of remember seeing that too. Let's see. Yeah, there it is. Oh, are you talking about that's for the RocksDB block
Yeah, for
chart
the
or the
RocksDB,
block hash?
exactly.
Yeah, and
I would,
their version of their block hash doesn't use our Jenkins. We tooled that in to use when we made our own version of it. We replaced their hash with the Ceph one.
mhm.
I don't actually know, is our Jenkins any slower than any of the other implementations? What's it, the Twister?
I'm not sure.
Um, okay, shoot, sorry, yeah. Anyway, yeah, go ahead.
I was just surprised to see it show up so high in the profile like that.
Yeah,
Also, Mercine Twister is a cryptographic or is a high quality hash. Our Jenkins is a low quality one. I would assume the Mercine Twister is slower.
okay. I know that back when I used to do ray tracing work, it was one of the faster implementations that we used for it, but I don't remember specifically why we would use that versus our Jenkins, because we don't really care about high quality, but okay. So also in here, there's the red-black tree, the standard map time being taken. I didn't include a trace that was deep enough to look at what that's actually doing, but
Yeah, some of that might be mitigated with the tcmalloc increased central heap size too. Be curious to see what the profile looks like after that.
yeah. Also, the current version of the benchmark works really differently, right? Like those traces were from doing like a single object with like a million keys on it. The new version is letting you specify like a number of objects to create with a smaller number of keys per object. So the trace might look a lot different.
Yeah, I'd imagine we might end up hitting more pieces of Blue Store rather than only RocksDB in that case.
Yeah, quite possibly. But the good news is that we still can do that, right? Like we could go back with the new version of the benchmark. You just specify one object that you want in the collection, and then a ton of keys on it. So we can still do those kinds of tests. What about multiple collections, Josh?
I don't think it makes much of a difference in multiple collections versus single collection.
Okay.
I mean, unless there's something I'm missing about serialization there. But you're going directly through the object store interface. You have control over the object sequencer and
Which I haven't done anything with at all, right?
right. Which should mean that you're getting like the most parallelism you can.
Is there anything else here that I'm missing, do you think? That would be good to include or look at?
Uh, What kind of like DB size are you testing with like so far?
I have no idea. Literally, I just started like throwing, objects and keys into things. So I mean, like, I know what the test does, right? Like this is like 100,000 objects with 100 keys per object, and the key length is like 64 bytes, and the value length is 256 bytes. So, I mean, you can roughly kind of figure out what RocksDB would see prior to space amplification.
Okay, so that's like maybe a gigabyte or two, roughly.
I didn't actually work it out.
I think if I heard you right, I think that adds up to roughly that. So it's probably worth trying with like larger data set sizes too.
Yeah, I know that MemStore uses like 30 gigs when I run it. So that's something.
Okay. I'm not sure that tells us too much, but other than how inefficient MemStore is.
Yeah, let's see. Okay, so if I do this, I get 320 bytes per key. Yeah, 100,000 keys per object, 100,000 objects with 100 of these per key. What does that end up working out to be? That's like 3.2 gigabytes, I think.
Okay.
Prior to space amp.
Right. That's not too unreasonable then. But we've certainly seen even like order of magnitude bigger in practice.
Yeah. It was enough that I actually started to see cache effects, right? That was what I was really going for, was I wanted that increasing the size of the blue store or the OSD target, memory target, and increasing the block hash actually made a difference for blue store. So that was really all I was focusing on.
Yeah, I guess for the file store case, you could even like run the system in low memory mode, where you don't let it use like with the kernel with low memory mode, so that you can't even use more than the data set size to force it to be able to go to disk sometimes. If you wanted to avoid the page cache effect entirely.
How do I do that? I mean, I think that's. Go ahead.
And because the kernel parameter you can set when you boot to determine restrict your memory to a smaller amount than what you actually have physically available.
Oh yeah, sure. So like globally, you could do that.
Yeah.
Okay.
Then you don't have to worry about like the C group, how that's playing with a page cache exactly.
Sure. I'll try to verify one way or another that how C groups actually work, because I'm still fuzzy on that.
Yeah, it'd certainly be useful to understand that in general.
Yeah, especially since that's what we do for containers, right? Like that's
Yep.
exactly what our real production stuff is doing, so we should understand it.
Yep.
One other thing I wanted to ask here, Igor, you looked at like collection prefetch and collection like caching, I think, a while back, and I think the thought was that prefetch was going to be good enough. Do you remember? Did you see?
Well, actually, this was obsoleted by fast APG removal. So the only place when suffered from on-collection listing is APG removals. Hence, I just replaced the prefetch with using the previous position for PG for removal.
Did you ever prototype like a cache?
Yeah, it was implemented in some way. I don't remember the details. There is a stale PR on that, as far as I remember. So,
yeah.
Well, don't remember if it was a cache or just. Yeah, it was a sort of prefetching and putting data into cache or something. Right.
Yeah, I saw a reference to this. I think maybe was it this thing? Just a second.
Let me check. I can try to find.
This is the one I saw earlier. I just posted in the chat window.
Yeah, that's it.
So I haven't looked at exactly what your code does here. Not really in detail anyway. But yeah, it looks like maybe you've made it so you can read from cache.
Well, the description is pretty straightforward, I suppose.
Yeah, I mean collection list prefetch. Yeah, I would have interpreted that, I guess, maybe I was mixing it up with your other prefetch work, or prefetching in RocksDB, right? Yeah. But yeah, this I see here in the code is like collection list cache. I wonder if this might be worth revisiting.
Well, just at the beginning of the discussion, what are you to achieve by this?
Well, so this is not really being tested in the benchmark right now, right? Like doing collection list itself. But given the other things I'm seeing in this benchmark, I wonder if it's going to be very slow in BlueStore.
All right. You mean your this new PR for benchmarking, right?
Yeah, I mean, if you look at it, I'm not doing collection list, right? But there's a bunch of other stuff, and it seems like any time we have a lot of data, the RocksDB block cache ends up becoming kind of worthless. So at least for iteration. So I was wondering, I guess my general high level theory is that the more we can cache that at the BlueStore level, the better off we might be in many different situations. One of which being the one that your old PR here is addressing, right?
Well, the question is, when do you need this sort of caching for collection listing? Well, the exact case is gremoval, but what else? And to be honest, I was pretty lucky with repetitive PG listing without any additional caching once I started to use previous position. I can't see that huge delays for collection listing as I did before. So,
okay.
Well, from the last case started to be around 2 milliseconds or even 200 microseconds to get 30 entries for PG removal versus up to several seconds original PG removal stuff.
Yeah.
On the same This was compared on the same node, on the same data set. Well, it was something like that. About buffered IO, BlueFS buffered IO set to false, getting around 8 seconds. When I set it to true, it dropped to 1 or 2 seconds, and then upgrading to Octopus 15.2.9, which that's this new removal. It dropped to, let it be, second.
How many seconds?
2 milliseconds.
2 milliseconds. So we went previously with buffered IO, we had 1 to 2 seconds. But with direct IO, it was 80, and now it's back down to like 0.2. Am I correct?
Well, it was 8 seconds with BlueFS buffered. BlueFS buffered IO to false. Around 1 second with BlueFS buffered IO set to true, and as far as I remember, 2 milliseconds.
Wow. Okay, so that's basically already fixed then.
And definitely that was the case when bulk removal happened before. So for regular usage, the difference is not that large. But that was the case when OSD degraded after bulk removal. Not OSD, but RocksDB.
For bulk removal, you mean like due to?
It was G removal caused by remapping or something like that. So PG moved to a different OSD.
Okay. And that was not caused by the RocksDB tombstone issue that we saw also, right? Where like bulk removal causes significant slowdown due to like.
Well, as far as I understand, currently we produce such tombstones case of large removals in a single shot, and
yes,
that's not the case for our regular PG removal. It takes just 30 entries and then removes them. So tombstones are not applied. But it looks like RocksDB might be still inefficient when there are bulk of removed records before.
Yeah.
But again, it's not that efficient since it depends on your access pattern. If you use iterators and save the previous position, it works pretty good anyway without compaction, things like that. It's a first search which might be inefficient. So, what's happening when you are removing PG on each collection listing to retrieve next items to remove? It has to run through a longer list of removed entries. I mean the original behavior. It always started from the beginning. So on the first iteration, it retrieves the first entries, then removes them. On the next one, it has to bypass somehow these just removed entries and find the next portion, and so on and so forth. And it looks like the farther it goes, the worse the behavior.
Yeah, that sounds right. My inclination is to want like an OMAP cache. I don't know if it's maybe more work than it's worth.
Well, I suppose we should start with the use case. So just find these use cases which suffer from.
Right now, we've got a couple of other people. We've got a couple of people, or at least one person right now, working on trying to take all of the different customer cases that we think may be related to slow OMAP performance and slow OMAP iteration, and kind of get them together so that we have that. It seems like it does whatever this is. It's maybe affecting many different use cases, though.
Yeah, just one thing to mention, that actually this patch for removal doesn't stop RocksDB in any case. So one might have some different scenarios when there are a bulk of bunch of multiple removals in RocksDB, and currently we are still we might still suffer from this.
Yeah.
One of the case is snap mapper records. Definitely. So if you case a lot of snapshots, might get bad performance as well. Maybe a GW, our example, but not sure I've heard about it suffering from it. But again, so I presume that any bulk removal might cause the slowdown. And
yeah, I agree.
Currently, we have just this one scenario fix. My second PR, which unfortunately don't have enough time to proceed work on, it improves some stuff, but it allows to run allows to fix bulk OMAP removals by using range deletes, subsequent compaction.
Yeah.
But again, that's probably not a 100% solution.
If you force the compaction after the range delete, though, that at least maybe makes it more viable.
Yeah, and actually, compaction is good in any case. If you applied range delete or not, this workaround to apply compaction to this degraded RocksDB was a workaround for a while. PG removals. So yeah, compaction goes around. Moreover, it looks like we can run online compactions on a subset of just removed records, and it doesn't impact the performance. So that's what I am doing in my second PR. But still an open question is how to handle bulk removals on unsorted records.
Yeah. So in the test case I've got here, in this PR I linked, there's no removals happening until the very end. So we're not even touching any of that. That's going to just be even worse, I think. This is just touching the cache and how effectively we can iterate or memory constrained scenarios. But you imagine that if you started doing deletions, then I imagine that these numbers would get even worse.
Maybe.
I think so. Sam, not to bother you again, but if I remember right, file store does something kind of strange with OMAP when it's submitting to RocksDB or previously LevelDB. It's not as straightforward as BlueStore. But do you remember how that works, or is there something? Is it easy to? Sorry, what was that?
Yeah, if you're not using cloning, it's a prefixing scheme. That's it.
That's it? Okay.
Pretty much, yeah.
Okay.
Are you asking how that could possibly result in higher performance? It couldn't.
Yeah, that's the only thing I can think of is that it's getting a bigger cache and it's
Memory
happy.
theory is, again, still a really good theory. File
Yeah.
store is using the kernel page cache. It's probably evading your C group limits, and it's probably quite a bit larger.
Yeah. It's probably not using a significant amount of block cache because I don't think file store changes the default. So I think it's like whatever we set the default block cache size to be. I don't know, it's like 500 megabytes or something. But it doesn't really matter because it's all buffered I/O going to whatever file system it's running on, I believe, for reads. So whatever page cache is left, if assuming the C group is actually limiting it, then if file store is not using a whole lot of memory, you might have a couple of gigabytes available for RocksDB's page, to use in the page cache for this, and that's good enough, and it just works. All right, well, this is all I've got, guys. Any other thoughts or questions or comments? All right, well, sorry, Igor, were you saying something?
No.
Okay. I'll keep working on this and let you guys know how it goes. Anyone have anything that they want to bring up before we wrap the meeting up? All right. Well, then, have a great week, everyone, and see you again next week. Thanks, guys.
Thanks. See you.